So for arc length is, for example, you are given this line here. So if we're trying to analyze the arc length, so in the area, what we did in the area is that we set different strips for us to determine a differential area. So in this case, since we are now analyzing the length of your line or your curve, so if we try to break it down into different parts, so instead of strips, we're going to divide them into different segments. So as you can see here, so it will depend on you on how many segments you're going to create. So in this case, there are 9 line segments. And then, for example, we're going to get one representative strip. So for example, this point here. So this portion here, points 8 to 9, will become our differential segment. So that's why it's called DS. And this one is from point 1 to point 2, or in this case, it's point 8 to point 9. So again, that's why it's point P sub I and P sub I plus 1, because it may represent any line segment or representative line segment in the given figure. So if we're trying to determine the distance of this differential segment or the length, so we can try to use the concept of Pythagorean theorem. So if we try to create a right triangle, so for example in this figure we're going to create a right triangle. So the y aspect is your differential y, and then your horizontal distance is your differential x. So of course, since we are analyzing it using the right triangle, so notice that in the given formula, it's more likely the same as your Pythagorean theorem concept. So if we try to determine this through your Pythagorean theorem, so c squared is equal to a squared plus b squared. So this becomes ds squared plus dx squared plus dy squared. And then your differential segment is equal to the square root of dx squared plus dy squared. So notice that our formula is looking like the same as the given formulas. So since we're not interested in the derivation of the formula, so we try to skip this part, as long as you know that the concept of the formula is coming from the Pythagorean theorem. So with further formatting and further processing of this formula or this part here, so this becomes this equation here. So we're going to have two equations for arc length. So one is with respect to x, and then the other one is with respect to y. So two formulas for the arc length. All right, so next is we try to solve our equations. So for example, you're given this equation and you're going to determine the length of this equation from 0 to pi over 4. So determine the length of y equals ln of secant x between 0 to pi over 4. So again, the creation of the graph should have a proper solution. So we also talk this one about in our meeting. So the graphs should have a solution or a provided evidence that you generated your graph. So di lang siya, so it's not copy pasted from any graphing calculator. All right, so of course, if you're going to plug in 0 and then pi over 4 in the equation, so it means that you're only going to have 2 points. And of course, with 2 points, you cannot determine that your equation is a curve, diba? So of course, you're going to create intervals in between 0 to pi over 4 to create different points in your curve. So again, as long as you have sufficient evidence in the creation of your graph, so muna siya. So I'll give credit to your solution. So one tip here is that since the problem is pointing out that your range of your length is in between this x range from 0 to pi over 4, so it means we're going to integrate with respect to x. So we're going to use the formula in terms of x, or with respect to x. So the formula is this one with respect to x. So from x1 to x2, then square root of 1 plus dy over dx squared dx. So for you to memorize the formula in an easy fashion, so the dx on the outside is the dx inside the radical expression is in the denominator. So marag atbang siya. Marag they are crossing each other. So that's how you remember the formula. So if it's in terms of dy, so dx over dy and then dy on the outside. So what you need to do here is we're going to determine dy over dx. So we're going to determine parts of the equation. So for the limits of integration, x1 to x2, so it is already given in the problem, which is this one. x1 is 0, x2 is pi over 4. Alright, so what's left for us to determine is now your dy over dx. So dy over dx is, of course, since we are determining the length of this equation, so we're going to write this equation first. So y equals ln of secant x. So as per the basic definition of derivatives, so the left side becomes dy over dx, the derivative of y with respect to x. So this will be, so again, this becomes ln u in our derivatives. So the corresponding derivative of ln u is du all over u. Okay, so meaning getting the derivative of secant is secant x tangent x all over the u, which is secant x. So cancel secant x. So dy over dx is equal to tangent x. So getting the square, since dy over dx squared is in the formula. So dy over dx squared is equal to tangent squared x. Alright, so we're now done with determining the different parts. So you won't be determining dx anymore because, of course, this is crucial in our integration process. So you need to at least to have dx on your equation for you to be able to integrate. So replacing the terms in your formula, so this becomes the integral from 0 to pi over 4, and then the square root of 1. So again, dy over dx squared is tangent squared x, so plus tangent squared x dx. So again, at this point, you may use your calculator in determining the answer for this one. But you can still further simplify this one so that you can help your calculator. So notice that this portion here is a Pythagorean identity, which is secant squared x. So this becomes from 0 to pi over 4 square root of secant squared x dx. And then eliminating the radical expression, so this becomes integral from 0 to pi over 4. And then what's left now is just secant x dx. So I think this one is a bit easier for the calculator to solve compared with the first one, which is a radical expression. So again, take note that if you are plugging in radical expressions in the calculator, so the calculator will have a longer time for it to solve. So medyo dugay-dugay siya makahatag sa answer compared to one. Oh, pwede ra siya kani yung i-plug in sa calculator, but if you try to compare it, so try comparing it now. So plug this one first, then compare it if you plug this one also. So there's a difference in the time that the calculator will give you the answer. So this will take a bit longer, and since this one is a simple equation, so mas dali siya maka-give sa answer. Okay, so 0.88. So again, since we are determining the length, so put units. Yes, you should make your calculator in radians mode because the limit is in pi over 4, is in pi. So don't forget that your calculator should be in radian mode. So radian mode because of this limit. So if you're dealing with any pi limits, so pi over 4, 2 pi, so don't forget to make your calculator in radian mode. So kanang naka-R. So it should be that in the upper screen, so the calculator should be in R. That's radian mode. So the normal default of your calculator is degrees mode, so which is D. Alright, so questions so far? So again, I think what's difficult later in the exam is the graphing portion, because for the formula, you can just use the formula and then upon giving in the equation, so you may directly use your calculator even if you don't want to simplify the equation further. So again, as long as the equation is correct, I'll give credit to it. So if your equation is not correct but you got the correct answer, so medyo kuan siya, di ba, murag shady kay inyong solution na. So for example, this one is not correct, is not correctly presented in your solution, but you got the correct answer. So of course, I can tell that the answer should not be correct because the equation presented is not correct also, di ba? So this is the solution. So again, you can your solution may be up until here only, or if you want to simplify it further, so you may go to this point here and use your calculator afterwards. All right, so let's try to determine the length of x equals 2/3 times y minus 1 to the power of 3/2 between y is greater than and equal to 1 but less than and equal to 4. So this is your limits of the length in y direction. So meaning we should be integrating with respect to y. So the formula in terms of y is the integral from y1 to y2 square root of 1. So again, it's squared. So if we are integrating with respect to y, so dy and then dy here, then dx. That's how you remember the formula, easier sense. Okay, so again, this one is your y1. This is your y2. And then dx over dy will be coming from this portion here, from the equation of the length. So determining dx over dy, so x equals 2/3 times y minus 1 to the power of 3/2. So this one is in exponential form or exponential format. This is u to the power of n. Alright, so derivative dx over dy, derivative of x with respect to y, is equal to 2/3. So this is going to be n times u to the power of n minus 1 du. So again, basic process of differentiation. So 2/3 bring down the exponent times 3/2 times y minus 1. 3/2 minus 1 is 1/2. Then derivative of the inside function is just equal to 1. So derivative of y is 1, derivative of negative 1 is 0. So this one is 1. So cancelling out 2/3 and 3/2 because they will cancel each other. So what is left is just dx over dy is equal to the square root of y minus 1. So getting the square of dx over dy, so that will be, so cancelling out the radical expression. So what's left is y minus 1. So plugging in the different values, so you're going to have from 1 to 4, and then square root of 1 plus, so dx over dy squared is y minus 1 dy. So simplifying it even further by eliminating the parentheses, so it gives us 1 plus y minus 1 dy. So cancel out negative 1, cancel out 1, and what's left in the equation is just from 1 to 4 square root of y dy. Okay, so again, you may plug this one in the calculator, but in my case, I just want you to help your calculator a bit, diba? So dili ingon na you have to totally solve everything, but try helping out the calculator that the equation that you're going to plug in is in the simplest format. So you can also plug this one in the calculator. So the length is equal to so that will be 4.67. So in fraction form, that's 14/3. Then decimal is 4.67, then units. All right, so questions so far or clarifications? Okay, so I think everything is clear. So since the arc length is just a simple topic because you're only dealing with one equation, so let's now try to rotate it about a certain axis to generate the surface area. So before that, so this is the solution there. So again, you may be up until this point only, or you can simplify it further and plug the simplest format in the calculator. So it's 14/3 or 4.67 units. So again, don't forget the family name of the answer. So units, square units, cubic units, depending on the application that you're going to solve. So volume is cubic units, area, surface area, as long as it's area, it's square units. Distance, length, any one-dimensional measurement, that is units. Alright, so now let's proceed to the surface of revolution, area of surface of revolution, or in simpler terms, this is surface area. So to determine the formula is we're going to have only two. So one is rotated about the x-axis, the other one is rotated about the y-axis. So notice that what is added in the formula is just this portion here, 2 pi y, and then the other one is 2 pi x. And then the rest of the formula is coming from the arc length equation. So where did this 2 pi y and 2 pi x came from? So the same as any other format. So for example, this one, we're going to represent point 2. So since point 2 is rotated about the x-axis, so for example, it's rotated about the x-axis, so the area that is going to generate is a circle. So same goes for point 1. So let's say I'm going to place it here. So the moment arm is this portion here. So if I rotate this point, it will create a circle. And the particular measurement that you're going to get from the circle is the circumference of the circle. So again, by formula of circumference, circumference is equal to 2 pi r. So 2 pi, and then this one is the radius. This one is the radius. So since the radius is the y direction, so that's why it's y if it's rotated about the x-axis. And then if we rotate it about the y-axis, so notice that our radius becomes the x distance. So 2 pi r. So if we are rotating about the x distance, I mean the y-axis, so the radius is the x variable, the x distance. So that's why rotating about the y, instead of 2 pi y, it is now 2 pi x. So this is from y1 to y2 there. Okay, so that is what is added here in the equation. So always take note that kung asa mag-rotate, so that will be your the radius is perpendicular to the axis of rotation. So similar to your method of disc and washer, so the strip should be perpendicular to the axis of rotation. In this case, the radius is perpendicular to the axis of rotation. All right. So for example, we're going to determine the surface area of the solid by rotating y equals square root of 9 minus x squared from x greater and equal to negative 2 but less than and equal to 2 about the x-axis. So again, since we are rotating about the x-axis, so you can just write the formula directly. So surface area is equal to 2 pi. So again, since we're rotating about the x-axis, so our equation is 2 pi and then y. So this is from x1 to x2. Square root of 1. So again, since we are in the x direction, so this is dx. So dx dy. So we're going to determine the different parts of the equation. So starting off with the limits. So x1 and x2 are already given, which is this range here. So again, of course, if you're going to generate a graph, so 2 points is not sufficient enough for you to create a curve. So you're going to create different points for you to be able to generate the curve. So next is the y parameter. So what's nice about this topic is we're only dealing with one equation. So the y portion here is the given equation. So y is equal to square root of 9 minus x squared. So getting the derivative, so dy over dx. So this becomes, so if you try to make this in exponential form, this becomes 9 minus x squared to the power of 1/2. So this becomes u to the power of n. So derivative is getting 1/2 down, then 9 minus x squared. 1/2 minus 1 is negative 1/2. And then the derivative of the base is negative 2x. So again, this format here is n times u to the power of n minus 1 times du. That's the derivative of the base. That's why we have negative 2x here. Alright, so simplifying this equation first is that we're going to eliminate 2 and 2 here. So what's left in the equation is negative x, so x in the numerator, and then bringing the negative 1/2 in the denominator to make it positive. So this becomes square root of 9 minus x squared. So this is your dy over dx. So getting the square of this one, dy over dx squared. So square of negative 1 is positive 1. Square of x is x squared. The square of the square root of 9 minus x squared is just 9 minus x squared. So we have solved this parameter already. So we're now ready to replace every term in the equation or in the formula. So this becomes 2 pi from -2 to 2. And then the y parameter is this one. That will be square root of 9 minus x squared, then times the square root of 1 plus x squared all over 9 minus x squared, and then dx. So take note, if you're going to plug this one in the calculator, so it's very obvious that the calculator will have a hard time. So try simplifying it first. So we can simplify this term here by combining the fraction. So from -2 to 2, and then square root of 9 minus x squared. So this becomes 9 minus x squared plus x squared all over 9 minus x squared. So cancelling out negative x squared and positive x squared. So this leaves you to 2 pi from -2 to 2 square root of 9 minus x squared, and then times this will be 9 all over 9 minus x squared. So simplifying further, so you can separate the radical expressions in the numerator and in the denominator. So 2 pi from -2 to 2, then square root of 9 minus x squared. So times square root of 9 all over square root of 9 minus x squared dx. So cancelling out these terms here because they can cancel each other, numerator against denominator. Then square root of 9 is 3. So this gives you 2 pi from -2 to 2, 3 dx. Or you are left with so you are left with 6 pi from -2 to 2 dx. So try comparing if unsay mas paspas on which is faster for the calculator to solve, this one or this one. So di ba kani siya mas dali siya, di ba? So I think there are only 3 options that the calculator can give you. So if you try to plug in complicated equations, so it's either the calculator will give you this answer, can't solve, or it could be either be math error if there's a problem in the calculator or in your solution, or it will give you the answer. So those are the 3 options that the calculator can give you. So first, that it cannot solve the equation, or second, it's math error, or the third one is it's going to give you the answer. So that's why, to avoid the first 2 answers, so try to simplify your equations first. So 24 pi, and then in decimal that will be kaning taas. Pero dugay magawa sa answer, no? So 24. Oh, so pwede ra po siya basta magawa sa answer. Pero if dili magawa sa answer, so meaning you have to simplify the equation. So 75.40. So again, since we are now solving for the area, it's square units. All right, so far no confusion for the formula on how to use the formula. Okay, so let's proceed to the last equation. Oops, no, advance that. So this is the solution. Okay, so let's so now proceed to the last problem. So we are rotating about the y-axis, so we're going to use the y format of the formula. So you can also tell that it's the y format because the range is in the y direction also. So I also forgot to say that on your graph, so you need to be generating the solid as well. So for example, you created this graph here. So let's say you have different points. Then afterwards is you're going to rotate it. So same goes for your area and your volume problems. So try to generate the volume or try to shade the area that you're going to determine. So by formula, so since we are in the y format, so 2 pi from y1 to y2. So again, since it's in the y-axis, so the radius should be perpendicular to the axis of rotation, so 2 pi x. And then the y format again, so squared, so dy, and then this one is also dy, so this one is dx. So we're going to determine again the different parts of the formula. So for the limits of integration, so they are already given. That's from 1 to 2. So next is the x value. So since this one is y, so we try to change it to x. So y is equal to cube root of x. So rearranging to make x first. So cube root of x is equal to y. Then cubing everything, x is equal to y cubed. So you now have the value of x. So lastly is we need to determine dx over dy squared. So this becomes dx, derivative of x with respect to y. So this becomes 3y squared. So getting the square, so dx over dy squared. So the square of 3 is 9. The square of y squared is y to the power of 4. So we're now ready to replace the terms in our formula. So this becomes 2 pi from 1 to 2. Our x value is y cubed. And then the square root of 1 plus 9y to the power of 4 dy. So again, you may place this one in your calculator. So if you don't know how to simplify even further, so i-plug in na lang sa calculator dito. Basta as long as the formula that you have presented in your paper is correct. So to simplify this is you can use u sub because I can see here that the degree in the inside of the radical expression is greater than the outside equation. So with this I can use u sub. So let u is equal to 1 plus 9y to the power 4. So getting the derivative, that will be 36y cubed dy. So notice that I have y cubed dy in the equation. So I can try to isolate y cubed dy. So du over 36 is equal to y cubed dy. So this becomes, the equation becomes 2 pi from 1 to 2, and then this becomes the square root of u, and then du all over 36. So this becomes pi over 18 from 1 to 2, square root of u du. So at this point you can manually integrate, because we cannot plug this one in the calculator because your u parameter is equal to this term here. So you can manually integrate first. So this becomes u to the power of 3 halves all over 3 halves. 1 half plus 1, that's 3 halves. So this is from 1 to 2. So this becomes pi all over 27 times u to the power of 3 halves from 1 to 2. Then you're going to have pi over 27, and then this is 1 plus 9y to the power of 4, 3 halves from 1 to 2. So evaluating manually, you're going to get the answer. So that's 199.48 square units. Again, you may up until this point only, then use your calculator. But again, if the calculator can solve the equation, so you have to go through this one, basic method of integration. All right, so any questions? All right, so since there are no questions, so I have posted the problem set in your canvas. So gamay ra siya. So 4 problems for arc length, then 5 problems for surface area. So this is the arc length problems. So gamay ra kayo. And then this is for surface area.